Okay, welcome back. This is the third example from chapter 12.2. Okay. In this example, what we want to do is we want to sketch the region of integration, and then we want to interchange the order of integration, and finally we want to evaluate this double integral. Now, even though this function is simple, e to the y squared, actually we do not have a elementary integral for this one. So, basically we cannot integrate this function as it is with respect to the y variable, we cannot do that. So, in this example we must interchange the order of integration. Now, okay, so first let us sketch the region of integration. Okay. Now, before we do that, let us figure out the limits. This inner integral says your y values goes from y equals x to y equals 1, and our outer integral says x goes from x equals 0 to x equals 1. Okay. Now, let us sketch this domain. So, this is the xy plane. Okay. Now, this is the line y equals x, it is a straight line and it goes to the origin. Okay. So, this is the line y equals x. Okay. Y equals 1 is a horizontal line, it goes like this. And finally, this says x, the lower limit of x is 0, which is this point, and then upper limit of x is 1. Okay. It is a vertical line like this. Okay. Now, let us figure out the region of integration, because we, as you can see, we have two regions. Now, at this point I think you should pause the video and you should try to figure out the domain of integration, but let us figure out the domain of integration. Now, if I think about this region, okay, let us think about this generic element. Okay. Now, if you fix the x coordinate and vary your y values, the lower limit of y is given by the x axis and the upper limit of y is given by the line y equals x. But this says the lower limit of y should be the line y equals x. So, our correct region of integration should be this part. This is the correct one, because if you think about this, the lower limit of y is given by the line y equals x and the upper limit of y is given by the line y equals 1. Lower limit of x is x equals 0, x equals 0 is the y axis, and upper limit of x is x equals 1. Okay. Good. So, we sketched the region of integration. Now, let us interchange the order of integration. Now, we want to reverse the order of integration. Okay. So, basically we want to write this integral e to the y squared. Now, we want to reverse the order of integration. So, now we have dx dy. Okay. Let us figure out the limits of this outer integral, because these two limits must be constants. Okay. Now, what is the lower limit of y? Okay. Now, the lower limit of y should be 0, the highest value of y should be 1. Okay. Because if we consider an element over here, its lower limit is given by y equals 0 and the upper limit of y is given by y equals 1. Okay. Now, let us go to the inner integral. The lower limit of this inner integral. Okay. So, what is the lowest value of x? The lowest value of x is given by this y axis, which is x equals 0. Okay. Now, what is the highest value of x? Well, if we consider any general element over here, the highest value of x is given by this line, which is the line y equals x. So, then this should be, if y equals x, x equals to y. So, this should be y. Okay. So, this is the way we reverse the order of integration for this particular problem. Okay, good. So, now let us evaluate this integral. Now, as I said earlier, it is impossible to evaluate this double integral, this integrand with this order of integration. But once we reverse the order of integration, we can solve this, and the reason is this. So, our inner integral corresponds to the x variable. So, it means now we can treat this integrand as a constant, because this function involves only the y variable. So, we can pull out this e to the y squared from this inner integral, then you will get e to the y squared times the integral from 0 to y of 1 dx, then dy. Okay. Integral of 1 with respect to the x is x. So, you have e to the y squared x, the lower limit of x is 0, upper limit of x is y, then dy. Okay. Apply the upper limit first and then the lower limit, you will get e to the y squared. Now, x equals to y, so you have y minus 0 dy. Okay. Now, if you simplify this integrand, you will get y times e to the y squared, and now we want to integrate this one from 0 to 1. Okay. Now, we can solve this integral using a u substitution. Okay. So, let me start from here. Let us take, so when you make a u substitution, always pick the complex part of the integrand. Now, for me, and I hope for you as well, this y squared is the complex part. So, let us use a substitution, u equals to y squared. Okay. Now, if u equals to y squared, this integral becomes integral, let us write this y as it is, but here you have e to the u, because y squared equals to u. Okay. Now, we want to find an expression for dy in terms of du. This is the relationship between u and y. So, basically u equals to y squared, and this says du equals to derivative of this, which is 2y times dy. So, in other words, dy equals to du over 2y. I hope you all can remember this from calculus 2. So, when you make a substitution, when you introduce a new variable, you need to find the corresponding expression for, in this case, dy in terms of your new variable. Okay. Now, the next thing is to figure out the corresponding limits. Okay. So, your y goes from 0 to 1. Okay. Now, what is the lower limit of u? Okay. If y equals 0, then u should be 0. If y equals 1, 1 squared is 1, u should be 1 as well. Okay. Now, with respect to the u variable, the lower limit is 1, upper limit is 1 as well. Now, fortunately, we can simplify this integrand. We can cancel this y with this y, and basically you will get integral from 0 to 1 of 1/2 e to the u du. But 1/2 is a constant, and we can pull out a constant from the integral sign. then you will get e to the u du. Okay. Now, integral of e to the u is e to the u, the same function. Now, let us evaluate this. The lower limit is u equals 0, upper limit is u equals 1. If you do that, you will get 1/2 times e to the 1 minus e to the 0. And if you want you can further simplify this. You will get 1/2 times e minus e to the 0 is 1. Okay, good. That's it. So, first we sketch the region of integration, and then we reverse the order of integration, and we solve this double integral. And with this I finish chapter I finished this example. This is the third example from chapter 12.2, and good and excellent. Thank you.